A network built right is awesome. I have some monitoring software that I use for many of the customers I support, and I always set them up. Well, I shouldn't say always. Most of the time, I set them up with a redundant network configuration where they've got dual switches that are managing kind of a distribution layer for them, doing the routing, dual internet connections, that kind of thing. And I love, it doesn't happen often, but I love it when it does, when stuff breaks. You're like, what? No, I mean, when you design a network right and you see in your monitoring system like a main device going down, you're like, bam, router down, and your phone does not ring because it failed over so well that nobody noticed that a major device just went down and they all got routed over another internet connection or another core switch or something like that. It's just a good feeling, and that's what this nugget is all about. First hop redundancy protocols. Think of it as your first line of defense. Understanding HSRP, VRRP, and GLLB. You got it, right? So we're going to take a look at each one of these protocols because they each have their own little niche that they fit in, and then we're going to focus in on configuration for HSRP. Here are your do I know this already questions. So if you do, you can move on to the next nugget. Can we start off with the statement, redundancy is good? When I first got into networking, someone made the statement, they said, 2 is 1, 1 is none. And they said it just like that, so fast, and I had to stand there and think. I was like, 2 is 1. Oh, okay, I get it. And now that's like my mantra. I always say 2 is 1, 1 is none. And you will have to sell redundancy from time to time as you're talking with management. And can I just tell you from my heart, I have gone through so many of these I'll call them negotiations, maybe discussions with management. I know how they'll go. Well, okay, yeah, we need to buy 2 of those $15,000 routers. And management goes, 2? Well, we only need 1, right? Well, yes, but for budget, and they go to, and can I tell you, I have lost those discussions if I stick to numbers alone. Let me tell you what has worked for me every single time, and I've gone through this many times. It's almost like I know the routine. The numbers, well, budgets, and maybe next year, and all the kind of stuff. And I just stop right there. I go, can I just talk to you from my heart? Let me just tell you a couple stories of what I've gone through. And I start relating stories of, I've been in a data center for 60 hours straight and no food, no sleep. And I'm sitting there on my iPhone on FaceTime with my daughter going, I don't know when I'm going to come home. And I'm breaking down because I've gone to delirium state. I don't know why it's not working. And I'm trying to relate to my 4-year-old. And I'm just like, Isabella, I'll be, Daddy's going to be home. And I mean, they're not made up stories. These have really happened to me, and I have never been turned down yet from management where they go, okay, I understand, because it's not just protection for the business, it's protection for you and for me from having those worst day of my life or worst week of my life experiences when things go down, right? So that was my quick pitch. Redundancy is good, right? Now, here's the problem. Every client can only have one default gateway. Can I just say this? If OSI would have run the world, remember OSI and TCP/IP competing protocols, TCP/IP ended up winning, bing, 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 OSI protocol went away. If OSI would have run the world, this would not be an issue because they actually had a routing protocol called ESIS. End system to intermediate system, where the clients participated in routing communication. They would find the default gateway closest to them. It's pretty cool, but that's not the world we're in. TCP/IP, you say this is your default gateway, that guy. So if that guy goes down, then we're stuck. We have to run to the computers and reconfigure them to use that guy as their default gateway, the redundant device as the default gateway. So well, what can we do? Well, that's where FHRP, first hop redundancy protocols, come in. It allows these routers to start communicating together to say, hey, I'm going to be the primary, I'm going to be the backup or the secondary, and we'll agree on a VIP, a virtual IP address. So instead of either one of us having and owning this 10.1.1.1 IP address, we'll just use that as our example. We'll use that as a virtual IP that neither one of us really own, but we can both take responsibility for. But it leads to some questions. Well, how does a router know when to take over? Well, me answer these one by one. They use hello messages. So they say hello, hello, hello. You can even go down to the sub-second timers on these things where you're like, hello. And they know the minute the router, the second, the sub-second that the router goes down so it can quickly take over. I mean, we're talking voice over IP, those kind of things that are very sensitive to disruption, right? So it can take over, snap of fingers. How does a client switch? The beauty is the client doesn't have to. The client is accessing the same IP address that they've always accessed. And that leads to the next question. What about ARP cache issues? I mean, if this guy has his MAC address and this guy has this MAC address, and ARP cache by default is 5 minutes, meaning when he figured out what the MAC address was for 10.1.1.1, he's going to remember that up to 5 minutes of idle time before he stops using it. So if this goes down, if that was your primary router and that was the MAC address, then it's going to be kind of hard-coded to go that way until it fails over. But they thought of that too. So in addition to a virtual IP address, they also have a virtual MAC address that is generated. So literally, the router takes over. So if this, let's say this is your primary router right there, it goes down. The secondary, the backup router, takes over from both the virtual IP and the virtual MAC, making ARP cache a non-issue. What if only the WAN link fails? That's a good question. I mean, if we've got our hellos going on between these routers, they're going hello, 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 and this is all good, but all of a sudden this link goes down. Well, how does the router know to fail over then? I mean, because he's technically still online, technically still communicating. Well, that is solved through something called interface tracking. So remember I said this guy's the primary and this guy's the secondary or the backup, the standby, active standby, that kind of thing. You've got this router. How did he become the primary? How did he become the active router? Well, he was elected. What determined his election? His priority. So you can set the priority of these different routers to say, well, if this guy's got a higher priority, then he's always going to become the primary. Well, with interface tracking, you can assign penalties to say, well, if you lose your serial 0/0 interface, you just lost 50 priority points, which drops you below what this guy would do. And we configure something known as preemption, to say, you know what, if my priority ever gets higher than this guy, I'm going to take over. I'm king of the hill and I'm pushing him down. So this guy would immediately move to the secondary role. And this guy takes over as the primary. So they've thought of everything. When they think of first hop redundancy protocols, this is how they work. Now, first hop redundancy protocols come in 3 different flavors: HSRP, VRRP, and GLBP. Each one having their own distinct advantage, HSRP being that it was created by Cisco and it was there first. 1994 was the year. Bon Jovi making records. Well, it's not that old. Maybe I'm just going too far back. But HSRP essentially was first of the game 5 years before the industry caught up with VRRP. Hello timer of 3 seconds, hold down timer of 10 seconds. It is a Cisco proprietary protocol, so of course you would only have Cisco devices that are using this. So you would create, as a matter of fact, back in 1994, they called virtual IP addresses phantom IP addresses, because it was before this whole virtual craze with VMware and virtualization all came about. Now everything is virtual, right? So we would have router 1, router 2. We would assign one IP address right here, one IP address right here, and then we would create a phantom IP address in between the two, and that would be HSRP. These guys by default would say hello to each other once every 3 seconds, and if they didn't hear from each other for 10 seconds, they would assume the other was down and take the other role. So if this was active, this was backup. If router 2 did not hear from router 1 for 10 seconds, it would consider him dead. Now, those timers are adjustable, and nowadays you can adjust them down into the millisecond range, right? So very, very fast. Virtual router redundancy protocol. 5 years later, as I mentioned, the industry caught up. That is one advantage, is VRRP is industry standard. But I would say yes, that is an advantage, right? It is industry standard. But I've never been in a situation where people purposely buy pairs of equipment from different vendors. You'll never see somebody at a service provider buy a CRS-1 and then say, well, let's use a Juniper device, sitting there as its redundant pair. No, you would buy a pair of 2 CRS-1s, not only from a design perspective does that just work better, but number 2, you're probably going to get a better deal. Cisco will sell you cheaper in a pack of 2 than you will buying one from each vendor. So industry standard isn't necessarily the biggest advantage, but I will say there is one. I think it's a pretty cool advantage of VRRP, and that is the ability to assign this virtual IP address or phantom IP address as one of the IP addresses assigned to the devices. See, in HSRP, you need 3 IP addresses, one here, and one for the virtual. With VRRP, you can get by with 2. You could do one here, which is also the virtual, and then one here, which is, its normal IP address, unless this guy dies, and then it takes over that virtual IP address. The reason I say that's advantage is I've been in a sticky situation where I get a block of 4 IP addresses assigned, and I've got a situation like this where I've got, multiple devices plugged into a switch. A lot of times it's an uplink. So I assign one here, one here, one here, one here. Well, there goes my block of 4. And if I'm using HSRP, I need one more for the virtual for each one. With VRRP, you can just kind of reuse one of the interface assignments as the virtual IP addresses. So those are the 2. That's it. Well, I should say hello timer and hold timer is lower by default, but this is just a configuration. You can make these just as fast. So that's why you might say, well, why is HSRP still around if we have this industry standard? Here we are, 2014 and beyond. Why do we still have HSRP? Because it's just as good. I mean, it really is. If you got Cisco, HSRP is the way to go. Of course, Cisco's going to be pushing that because they created it. The industry just copied them. So, 6 half dozen, however the rest of that saying goes, they're the same thing, right? GLBP is the other unique one. Gateway Load Balancing Protocol, created by Cisco for Cisco in 2005. It is identical to HSRP, but allows for an active-active load balancing setup. This is pretty cool. The way it works is we actually have 2 devices that, again, are configured the same way, but this time for GLBP. So they have the IP address here, IP address here. Here's our switch, right? IP address here, IP address here, and then you have a virtual IP address that GLBP uses. But one of these is actually designated as the active. Hang on, what was it? Active virtual AVG, active virtual gateway. Hang on, what's the term? Yeah, that's it. Okay, yeah, AVF is the other one. I was getting the 2 mixed up in my head. AVG. So the AVG, just think of him as the manager of the pair, right? So we've got router 1 and router 2, and let's say both of them have a, let's just say 100 megabit per second internet connection, and I want to, instead of just having one of these be active and the other being standby, I want to load balance between these 2 for my clients. Well, what GLBP does is this active virtual gateway creates one virtual IP address that these guys are all using for their default gateway, but 2 virtual MAC addresses. So what happens is the very first guy, let's just say we do a round robin, very first guy does an ARP request and says, hello, what is the MAC address for 10.1.1.1, my virtual IP address, right? The active virtual gateway will say, oh yeah, that's me. Come on over to me. Now, it has 2 virtual MAC addresses, so it's never using its physical MAC. So that guy goes, great, okay, he goes out this way. The next guy sends an ARP message saying, hello, who is 10.1.1.1? So that broadcast goes out, AVG gets it, and he goes, oh, actually, that's him. And he delivers the second virtual MAC address for this guy. So he ends up going out this way. So the next ARP, next ARP, next ARP. Is it exact? Is it packet by packet load balancing? No. But it's pretty darn good. I mean, you're equally balancing the clients between them. You can even do unequal load balancing. You could set up percentages where you can say, you know what, I want this AVG to respond to 20% of the clients with this MAC address, and I want it to respond to 80% of the clients with the other MAC address. You can do that, if you got 2 maybe unequal cost internet connections. So it's pretty cool, right? Again, it's not exact. There's no I should say there is the possibility that someone in that 20% could be a bandwidth hog with peer-to-peer file sharing enabled on their device and just suck up all your bandwidth. That's totally possible, but you get the point. For normal day-to-day business, it works pretty well. In this, the SPNGN2 series, we are going to focus on HSRP being our primary. The beauty of these 3 flavors of redundancy is if you learn one, you've learned them all. The commands are almost identical between them. You simply change out, instead of HSRP, you're configuring VRRP and type that syntax in. You'll see when I get into the configuration what I'm talking about. So the gateways are organized into what's called standby groups in HSRP. So we might say these guys represent standby group number 5. or 1 or whatever standby group number you want. One of those gateways will become active. The other will be in standby state. You can have more than one standby. You could have 2, 3, 4, different standbys, but they're all going to sit there as standby gateways. One of them is active. One of them is responding to the ARP request. The others are just waiting for him to die in some language, right? So that they can take over and assume responsibility for that connection. One phantom virtual router IP address and MAC address is generated, and then these guys are saying hello to each other once every 3 seconds, and they consider each other dead after 10 seconds. All right, let's have a little fun and take a look at the HSRP base configuration. I've got 2 routers. One of them, iOS XR, and the other iOS, so that way you're able to see it on both. The commands are slightly different. So where do you want to start? How about iOS? I'll bring over P1. So what I'm going to do is I'm going to actually do the ultimate travesty for a service provider series. I'm going to assign 192.168.1.x addresses to these routers. I'll say for any real Cisco person, if you are supporting a network and you use 192.168.x as your subnet addressing, you should I don't even know what to say there. You should be shamed. Now, I say that tongue-in-cheek because we all have them. I have many IT people. Every time we go back and we go, oh, yeah, that one. And we see a 192.168, we go, yeah, I started with that one. Never. Okay, anyway. So I'm going to do that for our service provider network. So this guy, let's make him .2. We'll make him .3, and then we'll make the virtual, the phantom IP address, .1, sitting here in the middle, which will be used for the clients. Now, we'll make him the active, him the passive, or the standby router. Let's do it. I'm on P1. Get into privilege mode. I'm going to go into, it's actually fast Ethernet 1/0. Let me just label the interfaces. F1/0, and then this one is gigabit Ethernet 0/1/0/1. Here we go. Interface fast Ethernet 1/0. I'll do no IP address. Yank off whatever's on there. We'll give it the IP address 192.168.1.2 class C. And now that's it. Now let's do the HSRP configuration. Now, HSRP, remember, is 1994, so that was before HSRP was a cool buzzword. Cisco came out with the word standby. So that's how you configure it on iOS-based routers, is by using the standby command. So I'm going to say standby, then we follow that up with a group number. So we say, what group number do you want to configure? Now you can have a whole bunch of groups. You have multiple groups on the same interface. There's all kinds of things you can do. I'm going to just use group number 1. The other side has to agree because they're going to be both in the same group. We'll do IP address. And you can, by the way, see there's a ton of different commands that we can do. I'll show you the key ones. The first one is the IP address. We need to say the IP address for this standby group is 192.168.1.1. That's the virtual IP address. Don't even need a subnet mask because it's assuming whatever IP address you gave the interface has the right subnet mask, right? So from there, I'm going to do standby 1 priority. We'll do the priority of, by default, they're 100. Everybody has the default of 100 as the priority. So we'll make this one the lesser priority. We want the other one, iOS XR, to become the HSRP active router. But you can see right now, it just went, it said, okay, I was standby, now I'm the active. Now, wait a second, I thought we wanted the other one to become the active. We do, but as of right now, the other one doesn't exist. So it's like, well, if I'm the only router, then I'm the active router. Right? So let's do standby 1, and I'm going to type in the command preempt. See, here's the deal. When we have a router fail, let's say this router goes down and this one takes over as the active router, right? When this one comes back online, it will not take over. It will not preempt the connection. So I always like using preempt, especially when we're going to use interface tracking, which I'll show you in just a second. So we've got preempt. Matter of fact, yeah, I had BGP and yanked the IP addresses, so we're seeing BGP collapse before our very eyes. So last thing I want to do is that standby 1, and we will do track, and let's just do serial 0. So I'm really just wanting to show you what this command does. You can, well, of course I don't identify which interface, right? Hang on, do show IP interface brief. Good. Okay, so let's do standby group 1 track serial 2/0, and take a look at this decrement value. How much do you want to decrement if that serial interface goes down? So this is very useful if maybe this was the active router and we said, you know what, if your serial interface goes down, well, you're no longer a good route, so I want you to decrease your priority by 50. That's what I was showing you just a moment ago. So let's just say the decrement will be 50. Good. Come back here and I'll do a show standby. Show standby. And we should see, correct, the state is active. Virtual IP address is 192.168.1. Notice virtual MAC address. This, by the way, is a well-known MAC address, 000C07AC. And then this is your group number, 001, or 01 is the group number for HSRP that we chose. So that will be what's given out for the ARP replies for the client. Okay, so let's now hop over to iOS XR. Shoot, just bring him right in the picture. And do this side of the configuration. Log in. And this one is a little bit different. Let's go into, let me just do a show IP interface brief. Get it up on the screen. There we go. We got our interfaces there. Good. So let's go into interface GI 0/1/0/1. Do a no IP address. And commit, get that off of there. Then we'll do the IP address. This guy was going to be 192.168.1.3. You know, right now, somebody at Cisco is having a heart attack because I am using a 192.168.1.3 on an iOS XR device. It's shame enough to use that on a Cisco device, much less a carrier-grade iOS XR device. Okay, so HSRP is now the command that we're going to use. We'll use HSRP... sorry, scratch that. Router HSRP. This is actually, so rather than keeping it under the interface itself, the iOS XR separates it into its own router configuration mode. So I'm going to do router HSRP. There's no group number or anything. It's just HSRP for the device as a whole. And I'm going to say this router is active for interface gigabit Ethernet 0/1/0/1, the interface that we just brought up, 192.168.1.3 up there. And then we can go through and start configuring our group numbers. Notice we're under the interface of HSRP, so all of our configuration goes under there. So this is what I was saying, HSRP, and we'll say our group number is going to be 1, you know, very exactly like the iOS, right? It's just instead of saying standby, it uses HSRP. Instead of saying IP, it's got IPv4. We'll do 192.168.1.1. HSRP 1, let's do priority. And we'll give it, well, let's just keep it at the default of 100, right? We'll do HSRP 1 preempt. If we have some kind of failure, we want this router to take back over. And then, I mean, we'll throw it in there. HSRP, why not? 1, we'll do the track, same kind of thing, track and interface, and we can go into gigabit. Well, I'm not going to put it in there, but it's exactly the same thing where you would decrement the priority if you ended up losing that interface so that the other router can take over. Good. So we've got that in place. Let's now come back. Instead of doing a show standby, oh, check it out. We just had, oh, and I loved having that in the background. We just had this guy do a little preempt action. It just said, I went from listen to active. And this guy was like, oh, I have been superseded. I've been kicked back down to standby because he came on with a higher priority and he said, I have preempt feature turned on. So now the state has turned over to standby on this P1 router. The iOS XR, if I do a show HSRP, same kind of configuration. And by the way, you can get this if you do a show standby, what is it, brief? Same. This is actually a nicer output. You see fast Ethernet 1/0 over here, group number 1. It is currently a standby. It is configured to preempt. This is fun. Cisco busted out a little ASCII art here, a little dash saying configure to preempt. Next is going to be a little soldier over here with a sword. I will preempt you. Standby is the local router. The active one, it's identified the iOS XR friend. And then we've got the virtual IP 192.168.1.1. Now from this same place, now you saw when I was hitting the question mark, there are all kinds of things that you can do. I will say one of the other common things is to adjust your timer. I'm like, oh, I never showed you this output. Same thing, right? It's just I'm the active one. Local router's active. This guy's my standby. Same kind of output. But I could go into global config mode, do router HSRP, and then go into interface GI 0/0/0 right there. And then I would do HSRP 1 timers, and we can go in and adjust our timers. Notice I could say I want my timer to bust out 10 milliseconds and use millisecond. Actually, I should have done that backward. Millisecond timer. I'm going to go down to how about 20. That's a nice low one. Now I will say, before you do something like that, number one, that will increase your convergence time, decrease your convergence time significantly, because it will be like hello, but you may be tapping out your processor on your device, because it's going to have to process all those at the control plane of the device. So this is the router has to think about these hellos to make sure it responds and everything is online. But you can go in and specify as low as you want. It's kind of fun when you have the switch in front of you and you do this. You'll watch the port go from this little steady blink, blink, blink to all of a sudden it's going because you get so much traffic going on there. So timers, adjusting the timers is another big one that people will commonly do. But why don't we do this for the last thing? Why don't I just kill a router? Reload. Standby card not present. Are you sure? Yep. I just took down the router. So need to do a backup. Proceed. All right, there we go. So we have now taken the router down. This guy, within 10 seconds, will take over. So let's just do a show standby brief. Still in the standby state. It's lost connectivity. So he's going to be saying hello to the other guy when the guy stops responding for hellos. Next hello sent. 4 state changes. Standby. There we go. Just took a second. At first I was like, he's down, right? Yep, you can see that the state just changed to active. Our 10 seconds went by. We now have another state change that was tracked between the two. So just verifying that HSRP is working and we have that virtual IP address alive and well. So there we have it, FHRPs in all their glory. We've seen the 3 different kinds of them. We've seen redundancy as good, and we've seen HSRP configuration. I hope this has been informative for you, and I'd like to thank you for viewing.